Hey class, so for this section of notes, we're going to start off on the applications for slope-intercept form. In other words, the word problems and how we can use that format to write them. Before I get into this, I just want to mention that you don't always have to write them with X and Y as we did in the last lesson. Like you can have other letters. For example, you could have, instead of Y equals, you could have C equals. Instead of number and an X, you could have a number and a B plus 7. That could be an example still of slope-intercept form. So we're going to apply that to these word problems because usually we're going to declare our variables to be the first letter of whatever we're talking about. Way it makes it easier to understand when we look at the problem. So example of how we're going to start out with that would be on number 5 here. And it says a cab ride costs $4 plus $1.75 per mile driven. Part A says write an equation to represent that cab fare and define your variables. That's the first thing you should always do with these word problems. In this case, my variables are going to be C to represent the cost of the cab fare. My other variable is going to be M. In a lot of cases, anytime it says per, it's telling you something that changes depending on another amount. That'll be your other variable. So in this case, M will represent the number of miles driven. And then I can use those variables to write the equation. My equation here is going to say the total cost, C, is equal to $1.75 for every mile driven, so 175 M, plus the $4 fee that always gets paid. That's going to be your equation. Part B just wants you to apply that equation. It says, if Clay's destination is 17 miles away, notice the miles, M. I'm going to plug that 17 in for the M. I'm going to substitute it. And he only has a total of $30. Will he make it? So we just want to see if we can plug that 17 in and if it costs him less than the $30 or equal to the $30 he has. So my problem, 1.75 M plus 4. I want to substitute in my 17 because it said 17 miles up here. And you can just type that all into your calculator, 1.75 times 17 plus 4. If you do so, you'll see that that equals $33.75. So does he have enough money to make it? No, he does not, because he only has $30. So no, he doesn't have enough money. Or he's $3.75 short, however you want to word that. So again, I'm going to use your odds for examples here. I'm going to let you guys try the evens on your own. I'll give you the answers to part B so you have something to check off of and see if you did it right before I close out this video. So number 7, it says there's a 22.5 ounce candle which burns at a rate of 1 ounce every 5 hours. Write an equation to represent the amount of candle left. So we want an equation that represents the amount of candle left. So I'm going to say C equals how much candle is left. And the other one is the piece that says burns at a rate of 1 ounce every 5 hours. So I need to keep track of how many hours are going by. So I'm going to say H represents our time period, our hours. Then we can use that to write our equation. This one's pretty simple. The amount of candle left would be your starting amount, which it started at 22.5 ounces, minus how much it loses per hour. This word, every 5 hours, you could read that as kind of 1 ounce per 5 hours. Anytime you see something like that, it's an indication you're going to have a fraction. So the 1 represents the 1 ounce per 5 hours. A fraction bar represents that per or every 5 hours. So that's how you come to that equation there. Again, we're going to plug in. It says, how many hours will the candle last? Well, if the candle's all gone, then the candle left, my C, would be 0. So I'm going to take my equation, C equals 22.5 minus 1 over 5H. And I'm just going to plug a 0 in for C, because I want to know when it's going to be gone. If it's gone, there's going to be 0 candle left. So 0 equals 22.5 minus 1 over 5H. Then just get the H by itself, and that will tell us how many hours the candle lasts. So I'm going to move 1 over 5H to the other side. So I've got 1 over 5H equals 22.5. To get that H by itself, 1H, we'll just get rid of the fraction. Whatever you have on the bottom in the denominator, you can multiply by to cancel that fraction out. So that leaves me just 1H equals 22.5 times 5, which is 112.5. So that candle would last 112.5 hours. Our last example for these applications says, Kaylee has a collection of quarters and nickels. All right. Write an equation to represent the total value of the coins. So we have to use some knowledge that we just know from life. Knowledge such as how much is a quarter worth, how much is a nickel worth, in order to do this. You're going to have 3 total variables because it wants an equation for the total value. Then we also need to keep track of quarters and nickels. So we're going to say T is the total value, the total amount of money that we have. Q is the number of quarters that we have. N is the number of nickels that we have. So our equation is going to be T, the total money, equals, we know a quarter is worth 25 cents, so 0.25, 25 cents for every quarter, plus we know a nickel is worth 5 cents, so 0.05 N, 5 cents for every nickel. Now there's our equation to keep track of the total money those quarters and nickels would be worth. And we want to apply that equation to answer part B, which just says the total value of her coins is worth $5.50. If she has 17 quarters, how many nickels does she have? So we're just going to substitute the 550 in for the total value and substitute the 17 in for the Q for quarters. Then we'll solve for the N. So I've got my formula, my equation, T equals 0.25 Q plus 0.05 N. All right, and we just want to substitute our numbers. 550 will get plugged in for T equals 0.25, and then for Q, it told us we have 17 quarters. Now plug in those 17 quarters. All right, and we're going to simplify that and get the N by itself. That will tell us how many nickels she has. So 0.25 times 17, if you multiply that piece out, you're going to get $4.25. Then you just want to get the N by itself, so I want to move that 425 to the other side. 550 minus 425 is only $1.25 left. So she has $1.25 worth of nickels is what this is saying basically. If we divide that by 0.05 to get N by itself, that will tell us exactly how many nickels is $1.25. So my nickels equal $1.25 divided by 0.05 is 25. She has 25 nickels. So I said I was going to leave the even ones for you to do. maybe I said the odds and misspoke. I'm going to give you the answers that go to the part B of these. That way you can check your work when you try these. So the answer to number 6 would be no. The Joneses would need $1,099. The answer to number 8, you do it correctly, should be $4.47. And the answer to number 10 would be 118 bags of popcorn. So that way you have some practice problems you can try, check your work, check your answers with. That covers the applications of slope-intercept form and linear equations.